Okay, so this is the first video on describing motion graphically. That's guide sheet number 7. Really synthesizes, puts together all the different types of graphs and how they blend together to allow us to analyze motion. You can check up on yourself by going through the MOP section of Minds on Physics section of physicsclassroom.com and trying some more of the KG sections. We did 1 through 4 before the test, the first test. There are many others that bring in the velocity time graphs and the combinations of the different graphs. So that would be a good way to check up on yourself. Alright, so in this first one we're looking at position time graph. It's important to note that the slope of position versus time is going to be delta x divided by delta t. That is your velocity. So the slope is the velocity, and where you're located is written right on the graph. Now, if the line is horizontal, that means 0 slope, and that means 0 velocity. That means you're at rest. If it's a diagonal line, then that means you're going to have constant velocity of some value. If it's a positive diagonal, it'll be a positive velocity. If it's a negative value, it'll be negative velocity. That means the direction that you're moving in, positive or negative. A curved line means a change in the slope, therefore a change in the velocity. So that indicates we're getting faster or slower, depending on which way the line curves. If the line is more gradually sloped, then that means we're moving slower than if it's steep. If it's steeply sloped, we're moving faster. Okay, again, that's position versus time. That's where we're located for every second of time. So here in these position time graph to the right, we have several questions to fill in, ones that would match. So first, which objects are at rest? We need any flat line. So A and E is the flat line. So A and E would be the answers. If it's going to be accelerating, we need a curve. That would be a change in the velocity. So the only one that has curve here is D. It's curving more and more positive as it moves in the negative direction. Which objects are not moving? Well, if they're at rest, that means they're not moving, so it's also A and E. Changes of direction would be indicated by moving a change of slope. So something along the lines of a positive slope to a negative slope, or a negative slope to a positive slope. In this case, that's a constant slope, that's a constant slope, that's a constant slope. This slope is showing us speeding up or slowing down, but it's not showing us that we're moving in a different direction. So in this case, it would be none of the above. Traveling the fastest would be the one that has the steepest slope. Doesn't matter if it's positive or negative, it's the one that has the biggest vertical change for horizontal change, and that would be B. Which is moving the slowest? Well, other than the ones that are at rest, which are not moving at all, then D is moving very slowly at the beginning. If you're talking about an average, the average of D would be a straight line through it. Well, that probably looks even more shallow than C, so I would pick D overall. C is also not moving that fast. Which objects are moving the same direction as object B? Now, the direction is going to be the slope. B has a positive slope, so we need any that have positive slopes. E doesn't have a slope, A doesn't have a slope, C is the other way, D has 0 slope at the beginning but then has positive slopes. So D is the one that's moving in the same direction as B. Okay, so those are some of the basics of the position time graphs, where we're located as we move through time. The slope is your velocity, and then you can read your actual position right straight from the graph if you have numerical axes. In the next one, we'll look at velocity versus time graphs.